Kinematics, velocity, time graphs. Kinematics describes the motion of points, bodies, and systems of bodies without considering the forces that cause them to move. Speed is the rate of change of distance with time. S equal to d over t. Velocity is the speed in a given direction. V equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. Acceleration is the change of velocity with respect to time. A equal to v minus u over t. Retardation is acceleration with a negative sign. So retardation is a negative acceleration. Examples. The diagram below shows the first 15 seconds of a car's journey. The car accelerates uniformly in the first 5 seconds at 4 meters per square seconds. Find the speed of the car when t equal to 5. Find the distance traveled by the car between t equal to 5 and t equal to 15. Find the average speed of the car for the whole journey. So we are going to say S equal to u plus at. U is the initial velocity, which is a 0. A is the acceleration, which is 4. And t is the time, which is 5. We'll substitute. 4 times 5 will give us a 20. Therefore, speed was 20 meters per second. Find the distance traveled by the car between t equal to 5 and t equal to 15. To find the distance, we have to find the area of the trapezium between the time 5 seconds and 15 seconds. So we are going to say distance is equal to half a plus b h. Where there's a, we'll substitute a 20. Where there's b, we'll replace a 40. And where there's h, we'll say 15 minus 5, which will give us a 10. 2 into 2, 1. 2 into 10, 5. Add 20 plus 40, you get a 60. 60 times 5 is 300 meters. Average speed is equal to distance over time. The question is saying, find the average speed of the car for the whole journey. So for the whole journey, it was from 0 to 15 seconds. But we've already found the distance from 5 to 15 seconds. So we have to find the distance from 0 to 5 seconds. So we are going to say half BH. We are going to say half times 5 times 20, which is going to give us a 50. Add 50 to 300, you get a 350. So the distance was 350 and the time was 15 seconds. Divide 15 into 350, you get 23.3 meters per second. Question 2. The diagram below is a speed time graph of a particle which accelerates uniformly from rest for 12 seconds until it reaches a speed of 24 meters per second. It moves at constant speed for a further 12 seconds before it accelerates uniformly for another 6 seconds to a speed of v meters per second. Calculate its acceleration for the first 12 seconds. Find the distance which the particle covered in the first 24 seconds. Given that the total distance covered was 600 meters, calculate the value of v. So we are going to say a equal to v minus u over t. Where there's v, we'll replace the 24, which is the final velocity. Where there's u, we'll replace the 0, which is the initial velocity. Where there's t, we'll replace the 12, which was the time. 24 divided by 12 will give us a 2. Therefore, the acceleration was equal to 2 meters per square seconds. Find the distance which the particle covered in the first 24 seconds. So we are looking at the area of that trapezium. We are going to say A equal to half, open your brackets, A plus B, close your brackets, H. Our A is 24 minus 12, which is going to give us a 12. And our B is 24. And our height is 24. So we'll substitute. 2 into 2, 1. 2 into 24 is a 12. 12 plus 24 will give us a 36. 36 times 12 is going to give us 432 meters. Given that the total distance covered was 600 meters, calculate the value of V. So here we have two trapeziums. The first one, which was covered in the 24 seconds, and the next trapezium is from 24 to 30 seconds. For the first one, the distance has already been found as 432, so we'll replace the 432 there. And the next trapezium, we have our A is 24, our B is a V, and our H is 30 minus 24, which is a 6. So we'll solve it like that. 2 into 2, 1. 2 into 6 is a 3. 3 times 24 will give us a 72. 3 times V will give us a 3V. Like that. 432 plus 72, and then we'll take it to the left side. So it's going to give us 96 equal to 3V. To find the value of V, we'll divide both sides by 3. Our V is equal to 32 meters per second. Question 3. The figure below shows a speed time graph of cars driven by Mr. Banda and Ms. Kapila. Find the acceleration of Banda's car during the first 10 seconds. Calculate how far Kapila's car traveled before coming to rest. What is Banda's acceleration between the 25th and 30th seconds? So we are going to say A equal to V minus U over T. Our V is 30, our U is 0, and our T is 10. 30 minus 0 will give us a 30. 30 divided by 10 will give us a 3. The acceleration was 3 meters per square seconds. Calculate how far Kapila's car traveled before coming to rest. So we are looking at the distance from 0 to 50 seconds. We have two triangles there. The first one has a base of 45. The next one has a base 50 minus 45, which is giving us a 5. And the height was 20. So we'll substitute. 45 times 20, 900. 5 times 20, 100. Half times 900 will give us a 450. Half times 100 will give us a 50. Therefore, the distance was 500 meters. What is Banda's acceleration between the 25th seconds to 30 seconds? So we are going to say A equal to V minus U divided by T. So where there's V, we'll replace a 0 because it is the final velocity. Where there's U, we'll replace a 30. So we have 0 minus 30, and the time was 30 minus 25, which is 5 seconds. 0 minus 30 will give us a negative 30. Divide negative 30 by 5, we have A equal to negative 6 meters per square seconds. This one was a retardation. Question 4. The diagram below shows a speed time graph of a car A and B. Car A starts from rest and accelerates uniformly for 4 seconds until it reaches a speed of 10 meters per second. It moves at this speed for 8 seconds, then accelerates until it stops. Car B starts from rest and accelerates uniformly for 4 seconds until it reaches a speed of V meters per second. It moves at this speed for 4 seconds, then accelerates until it stops. Calculate the acceleration of a car A during the first 4 seconds. Given that both the cars cover the same distance, calculate the average speed of car, the maximum speed V of car B. So we are looking at the average speed of car A and the maximum speed V of car B, which it reached. So we'll take it step by step. Acceleration is equal to V minus U over T, where there's V will replace a 10 since we are looking at car A here. The final velocity was 10, the initial velocity was 0, and the time was 4 seconds. So if you divide 10 by 4, you get 2.5. Acceleration was equal to 2.5 meters per square seconds. Given that both cars cover the same distance, calculate the average speed of car A. So the average speed, first we have to find the distance from 0 to 16 seconds. So we have to get the area of that trapezium. From 4 seconds to 12, we have 12 minus 4, which is giving us 8. And then we have 0 to 16. So we have half A plus B times the height, which is 10. So if you solve the area of that trapezium, you will find that the distance is 120 meters. So speed is equal to distance over time. Our speed is equal to 120 divided by the time, which is 16 seconds. Speed is equal to 7.5 meters per second. The maximum speed V, which the car B reached. So we are looking at the speed of the car B. So if we have to find the area of that trapezium under B, we have to find a 120, since the question is saying, given that both the cars cover the same distance. So we are going to say D equal to half, open your brackets, A plus BH, where there's D, we'll replace a 120, since we found the 120 for the distance under the car A. Half, our A is 4, subtract 8 minus 4, you get a 4, and our B is 12. Our V, we don't know what our height is, so we'll place a V. So if you add 4 plus 12, you get a 16. Multiply half times 16, you get 8. So we have 8V equal to 120. To find the value of V, we'll have to divide both sides by 8. Our V will be equal to 15 meters per second. As simple as that.